Yes, I am audible. Yes, I am audible.
Yes, sir.
Yes, let me start. Briefly introduce yourself.
Yes, sir. Hello, sir. Good afternoon. I am Poulami Ghosh. I am from Hooghly, West Bengal. I have passed 10th board from West Bengal Board of Secondary Education in 2024 with 86% marks. Then I have passed 12th board under West Bengal Council of Higher Secondary Education in 2026. Then I have dropped for 1 year to for medical preparation, and then I have pursued my graduation in BSc Chemistry under University of Calcutta and completed with 74.60% marks. And then I have admitted in MSc in 2020 and completed my masters in 2022 from Central University of Punjab.
Yes, good.
And I have, yes, sir.
Yes, your name is Palmi Ghosh. Yes, what the meaning of your name? Explain. How do you feel about your name?
Sir, my name sounds like very sweet, and it is very common in West Bengal. And the meaning is not like there is a exact meaning of my name. By from mythology, it there mentioned that Pulumi is the daughter of Devan Pulaman, and she is the wife of Deva, king of Deva, Indra. So the Pulumi is the wife of King Indra, king of Deva, Indra.
Yes, good. Your hobby is Bharatanatyam. Yes. So describe your hobby.
Yes, sir.
How to use your each one in a day, week, in a month.
Sir, I have learned Bharatanatyam at the age from the age 6, and I used to try to practice every day, but now it's not possible to practice every day. I like the classical dance very much, and that's it.
Yes, good. Next, your native place is Hubli, West Bengal. Yes.
Yes, sir.
How do you feel about your district in West Bengal? Explain briefly.
Sir, Hooghly, the name Hooghly came from the river Hooghly River, which in our district, the river Ganga is named as Hooghly River, and the district is situated at the bank of Ganga. And there, in our district, there are so many religious spaces. Like one of the mandir is temple is there, which is Tarakeshwar Shiv Mandir, and so many devotees from West Bengal comes there in the month of Sawan. So, and this district is situated in the south of West Bengal.
Yes. Good. Yeah, next move on laboratory sections. Yes. Have you prepared laboratory sections? What is lab?
Yes,
How do you feel about lab? What the role of lab in your life? Explain.
uh, Sir, I have not learned the laboratory process. I could not learn the elementary analysis and all that. I, I prepare this for the next step.
Okay, okay, no problem. Yes, your MSc project is metallic catalysis and radical casting cyclization. Yes. What the application of these
Yes,
topics?
sir.
What the uses of this topic? Explain briefly.
Uh, Yes, sir. Sir, the cascade reaction means the reactions, a process which completes in a single step reaction. So by this we can save our time, and since it's a single step reaction, the uses of reagent and labor and obviously the time will be limited. And by this we are trying to synthesize the drug molecules in our lab, and we have tried to generate, since it is a radical cascade cyclization, we have used metal as a catalyst to initiate the radical. And since radical is a very reactive molecule, we know, so so this reaction is quite fast, and we can get the drug by this process. So our target was to synthesize a drug, especially the cancer-related drug. And my target molecule was dihydroisoquinolinone. The previous study has been shown that this molecule has a cancer cell activity.
Yes. What the use of these one in your, our society and in human life? This topic.
S- Sir, my target molecule shows that by the previous study, it is proven it has some biological activity, and it can be used as a drug for cancer. So we are trying to synthesize the drug molecule. So if it can prepare, then it can help the society as to give prevent cancer medicine. So we're trying to synthesize that molecule.
Yes. Next topic is BRC. What is BRC? What the main application of BRC in our country?
Sir, BRC is the Bhabar Atomic Research Center, which is situated in Trombay, Mumbai. So its main motto is the service of our country, and mainly they are focusing on the nuclear power, nuclear energy generation, and also they are focusing on some biology and like radiation section, which is and medicine also, and their focus is the isotopic application in some industries. It is main motto is to generation nuclear power, nuclear energy.
Yes. When did it stabilize?
So 1954.
Yes. First director of chairman.
Sir, Dr. Homi Jahangir Bhabha.
And presently director. Presently Dr. Vivek Besin. Yes. Next question is why will you become a scientific assistant in BRC? आप साइंटिस्ट क्यों बनना
So
चाहते
that since it is a renowned organization in our country, and there are a huge number of Department of Atomic Center, so I can be a part of this organization and can serve for my country.
Yes. What the role of scientific assistant in BRC? Role scientific assistant in a BRC role is technical department, na? Apparatus uses. Next is what is scientist? What the major responsibility of scientists in our country?
So the main purpose is the research and development. The main purpose is the innovation and
Yes, आप थोड़ा इस पे वर्क कीजिए, साइंटिस्ट मेजर रिस्पॉन्सिबिलिटीज, यस थोड़ा इसको स्टडी कीजिए, ज्यादा से ज्यादा टाइम निकालिए. यस, टुडे टॉपिक, दिस टॉपिक हैव यू प्रिपेयर्ड फॉर मॉक?
Sir, chemical kinetics. In the previous day, we have started with chemical kinetics and
Yes. Last one topic
First order reaction.
we have discussed. Second order.
Yes, sir. First order reaction and the graphical representations.
Second order yet completed? You only first order?
No, sir. Only first order.
Yes. The next move on second order of reaction. What the main application of second order of reaction?
Application.
Yes, what is second order reaction?
Sir, second order reaction is the rate of the reaction is proportional to the square of the concentration. So if we double the concentration of our reacting species, the rate will be the square of it. Means it will get 4 times.
Yes, what the life of second order of reaction? Half life? Yes, explain second order of reaction. Yes.
Then here A3 is the concentration of B at the time of T and A0 is the initial concentration. If we consider the half-life, means T equals to T half, then K T half is B. Then AT is going to be A0 by 2. And calculating.
Yes. Second order of reaction, what will be the graph? Rate versus concentration, rate versus time, या concentration versus time?
The rate versus concentration will be straight line, and the slope will be uh, concentration.
Yes.
So, the concentration versus time for the reactant.
Yes.
They're taking that concentration of
Yes. Yes.
so here we are taking that the reactant species is only 8, and or the or it is similar that if the reactant species is 2 and their concentration is equal, then the reaction will be like this, and we can get this type of graphs. And if the concentration of the two species are different, then the reaction, the rate law will be different, and it becomes like it will depend on both of the concentration of both the reactant species.
Yes. What the example of second order of reaction?
Sir, N2O5 to N12 plus N25.
Yes, SN2 reaction is so many examples. SN2 second order, SN2 is second order reaction, SN1 first order reaction. Catalyst presence of zero order of reaction. Yes, no?
Yes, sir.
Any limitation of second order of reaction?
Sir, the in the kinetics, for a reaction, the molecule should come close to each other and collide with each other. So, in a second order reaction, since there is more than one molecule are present, so at a time, at a given time, the more number of atoms coming to each other and collide is quite difficult, uh, rather compared to first order. No, sir,
Okay, no problem. You look them, you have to study about these one. Yes, no. Next move on, next topic is third order of reaction. What the main application of third order of reaction? Yes, third order of reaction.
Sir, application means I don't understand.
Yes, what is third order? Third order, main function of third order of reaction, main function.
Okay. Sir, so the rate of reaction is proportional to the third root of the concentration of the reacting species. So if we change the concentration of reacting species, and the rate will be increases or decreases like the third root of this sorry, in the
Yes, what the graph of third order of reaction? Rate versus concentration and concentration versus time. Yes. Yes, right. Graph of rate versus concentration, concentration versus time, two graph of third order of reaction.
rate your straight line with the very steep slope. Rate of the reaction. Sir, sir, I can't, sir, I can't read the concentration versus time.
You okay? You look them the graph of third order of reaction. Yes. No?
Okay.
Any limitation of third order of reaction?
Sir, we are starting the elementary reaction here.
Okay.
So we know that the molecularity and the order is similar for elementary reaction. In this case, we are taking like the three molecules in a reaction. So at a given time, the three molecules come close to each other, and collision is quite difficult for the reaction. So the formation of product many leads to this.
Yes, good. What are the example of third order of reaction? 2NO plus O2, 2NO2. Yes. What the half-life of third order of reaction?
General question is like sir, 3 by 2 into 1 by A0 square. And sir, half-life, T half will be 1 by 2 into K and 3 by 2K into 1 by A0 square.
Yes.
K is the right one.
Yeah, next move on. Next new topic is activation energy. What is activation energy? What the main application of activation energy in chemical kinetics?
That means we know that in a reaction, the bond between molecules should be break to proceed to form a product. So so a molecule should give a certain amount of energy to break its bond. So the total energy is called threshold energy. But molecules already in part already contain some energy, so it's called energy. The energy which we have to provide to acquire the threshold energy is called the activation.
Yes. What is threshold energy?
So the threshold energy is the the total energy to break a bond, but it's not equals to the activation energy.
Yes. What is actual energy? What the difference between actual activation and threshold energy? How to define of each one?
Sir, can I explain it with a graph?
Yes, yes, sure.
Sir, if our molecule is A and this much amount of energy is the actual energy of this molecule.
Yes.
And this energy is called the threshold energy. We have to pass through this energy to get converted into product, but our molecule already contains this much of energy, so we have to provide only this much of energy to convert into product. So this energy is called activation energy. So we are providing this energy to activate the molecule to get converted into this product. So it this energy is activation energy. Activation energy.
Yes, good. What the difference between exothermic and endothermic reaction?
Sir, in a exothermic reaction, uh, the product the energy of the product will be less than the actual molecule. So in this case, the energy will release for this reaction. And the endothermic reaction is, at the end of the reaction, it will absorb energy from the environment or from the reaction vessel, and the energy of the product will be higher than the actual molecule in case of exothermic reaction. So this is the example of exothermic reaction. And if we consider endothermic reaction, so it will like this.
Yes.
In this case, the delta E will be greater than 0. And for exothermic reaction, the delta E will be less than 0. And the energy, that means energy will be energy release in this reaction.
Yes, good. Any limitation of activation energy?
Uh, Sir,
No problem. You look them. You have to study about this. Yes. Next question. Next topic is Arrhenius equation. What is Arrhenius equation? What is the main application of Arrhenius equation? How to drive of this derivation?
Sir, from Arrhenius equation, we usually calculate the rate constant, and with respect to the amount of activation energy, and the equation will be K is equals to A into e to the power minus EA by RT, where EA is the activation energy, R is universal gas constant, and T is equals to temperature.
Yes. How to determine of activation value, activation energy value from Arrhenius equations? What does graph and slope?
Sir, graph which for which versus which?
Yeah, graph versus log versus time.
Log K versus time.
Yes, log K versus time. And concentration versus time.
Yes, sir.
हाँ हाँ अभी करता हूँ
Sir,
फिर यस कैरी ऑन
sir, sir, in this case, log K is inversely proportional to T, minus T. So if T increases, 1 by T decreases, that means log K will decrease. Sorry. Sorry. 1 by T decreases. 1 minus 1 by T will increase. And that means log K will increase. Writing. Is it like this? Sir, log K versus 1 by T will be like straight line, the slope of minus EA by R. But
यस
sir, I have to learn about log K versus T. Actually, it is log K versus 1 by T.
यस log के वर्सेस 1 by t is right. Any application, any limitation?
Sir, limitations I can't find in books also. Can you please?
Okay, no problem. I will send you on WhatsApp. Yes.
Okay, sir.
Yes. Next topic is catalysis. What is catalysis?
Sir, sir, can I move to opposing reaction, catalysis reaction? I have to learn for the next day.
Okay, no problem. Yeah, next day, today mock time is 40 minutes. Next day we will discuss is next new topic catalysis and left part of chemical kinetics. Yes, no?
Okay, sir.
Catalysis.
Sir, tomorrow from 3 p.m. I have presentation in our lab. So, can I start in evening or
Yes,
morning?
evening. Yes, evening. I will you send on text which time. Yes, no? After 5.
Okay, sir. Sir, yes, sir. Anytime I can join. Sir, I will give the remaining part of the kinetics tomorrow.
Yes. Catalysis, steady state approximation, equilibrium, Lindemann theory, collision theory, Michelmanson.
Yes, sir.
Mm, yes, fast reaction, slow reaction, parallel reaction, conjugative reactions,
Yes, sir.
collision reactions,
Everything.
integrated complex theory, transition state theory, these type of topics. And you look them and you have to study about these topic limitations. Yes, no?
Yes, sir.
Search on Google, yeah, any other books. K.L. Kapoor. Yes, sir.
Sir, in K.L. Kapoor, I can't find the limitation of first order, second order, third order reaction.
No problem. I will send you on WhatsApp. Yes.
Okay, sir. Okay, sir.